Good morning. I'm Pat Harrington. I'm here representing AFCEA and the Greater Augusta chapter. And we have a series of CEUs, so you're all kicking off this morning with one of our more interesting ones of the operational technology and securing our infrastructure. This session has to go for the full 60 minutes for those of you that are trying to get continuing education credits. 5 minutes before the session ends, the computers will turn on for you all to scan your badges as you head out. So make sure you scan your badges within the first 5 minutes after the session ends, just so that you can get your credit. And today we have with us David Forbes, and he's here from Booz Allen Hamilton, and I'm going to let him take it away.
Hey, Beth, thanks very much.
Thank you.
All right, we have slides, and we got a good crowd here to kick off Tech in Augusta, so I really appreciate everyone taking some time here to join me this morning. As Pat said, I'm Dave Forbes. I'm a director of cyber physical defense at Booz Allen Hamilton. I lead our operational technology, weapons systems, and space mission systems enterprise at Booz Allen. How many people here in the room are working cybersecurity? Okay. Of this group, how many of you work with, around, understand, have background and experience in operational technology? Okay, great. Well, what I really want to do today is offer a practical presentation on securing critical infrastructure and how operational technology factors into securing our critical infrastructure in today's threat environment. So as we go forward, I'll stop a few times along the way, ask for your questions and thoughts. So please feel free to be open and share your thoughts, because what we want to do is make this as useful for you as possible and for you to walk away with some information that you can take back to your organizations, and most importantly, take it into the field as you go and support your organizations and your organization's mission. So what we really want to cover today is look at, the rising priority of securing critical infrastructure. Okay, we're going to talk a little bit about the threat. We're going to dive kind of deep into operational technology. And then I want to cap off by talking about some things that we can use to go to the field. When you talk about securing critical infrastructure and operational technology, there are several directions that you can go in. It can be a very broad and deep field, but what we want to do here is provide you some things that you may know, may not know, some different perspectives. I just want this to be useful, right? Everyone loves a good panel, and I have the opportunity to be on those things once in a while, but the opportunity to train and actually share information that can be useful for all of us to take out to support our mission and actually try to secure critical infrastructure, I think that's a pretty exciting opportunity. So let's start by looking at where we are today with critical infrastructure and securing critical infrastructure. In my view, this really is our time. Many of you in here who raise your hand and say that you've been working in OT for some time probably have been through those discussions and battles where you talk about the importance of OT in securing infrastructure. You talk about OT versus IT, and we'll talk a little bit about that. But the 2023 National Cyber Strategy, rolled out last year, presented 5 pillars to us. Pillar 1 is defending critical infrastructure, right? So talk about an opportunity to look at critical infrastructure cybersecurity as a national imperative. This is our time to do that. There are 5 pillars, but the fact that we're seeing this emphasis at the executive level on protecting critical infrastructure is a step in the right direction. Also of note is that the strategy had committed to rolling out a series of PCAST, President Councils of Science and Technology. And the first one of those PCAST was a PCAST on cyber physical defense, right? So here we have a national cyber strategy that emphasizes protecting critical infrastructure, and they make the decision to roll out PCAS number 1 that focuses on cyber physical defense. Right? So a step in a good direction. If you have an opportunity to read the report that came out of that PCAS, and I'm happy to discuss that with you or provide that to any one of you afterwards, you'll see some very specific goals and expectations and some taskers that came out of there that specifically emphasize the focus on operational technology, cyber physical defense. What kinds of things do we need to do to really get at protecting critical infrastructure? So let's just take a look at, for a second here, when we talk about OT systems, what are we talking about here? Operational technology refers to the security, operational technology refers to physical systems and processes. Okay, when you look up here at the chart, common examples of physical systems and processes are found in weapon systems, power systems, logistics systems, wastewater treatment data centers, building control systems. It's very important that we kind of get this fundamental understanding up front that OT is not IT, IT is not OT. Okay? IT, information technology, is about the data. OT is about physical systems and processes. Now, what's challenging about OT? Okay? Well, in OT, uptime really is paramount. You just can't take a HVAC system or a force protection system or a launch pad or a fire alarm system or a airfield lighting system and just take it off the grid for a while to repair it or attach on it. You just can't do that because the mission is dependent on those physical systems and processes. At the same time, we have mission dependence on these OT physical systems and processes, but they're legacy systems. I mean, in many, many cases, both in the commercial and the federal sector, you're looking at operational technology that has a life cycle of 20 to 30 years. So the reason that this is such an opportune time for us to be participating in this discussion and for you all to spend time in this training is that OT is really important. There's never been a time where OT has interfaced more with other weapon systems and platforms that are critical to our mission. So as we gather here at FCA and TechNet, very close to Fort Eisenhower, we're really focused on the national security mission. Okay. So you become increasingly aware of legacy systems, mission-dependent, physical systems and processes that have been around for 20 to 30 years. And in most cases, were never installed or purchased with the intent of being secure. Okay? So I see a lot of head nods out there because you're all operating in this mission in different roles and responsibilities, but you're seeing this. One of the really neat things that I get to do, like many of you, is go out into the field and see what the asset owners are dealing with to support these missions with OT. And it's amazing what you find. We'll talk a bit about the different types of installations, but every installation, every base is different, has a different mission, and each one of those OT environments presents different challenges. So the takeaway here is OT, insecure by design, legacy systems, never intended to be secure, but we're talking about physical systems and processes, not IT. Okay? A lot of differences there. We'll talk a little bit more about that as we go. So let's talk a little bit about the threat. This is a depiction of what, I call cyber-physical threat landscape. And this is one battle space. When you look at the threat environment that we're dealing with today, it's really one continuous battle space. And I'd like to start there in this discussion. The adversary, nation states in particular, don't view the United States as a federal government, a Department of Defense, a Department of Treasury, a commercial sector. They view us as one connected battle space with a whole lot of seams and vulnerabilities. In this increasingly digital environment, we have just an exponentially increasing number of connected devices. there's approximately twice as many connected devices as there are people in the world. So when you look at this opportunity for disrupting our mission, we have to consider all the environments. We really have to consider the defense industrial base, manufacturing sector, the weapon systems, the depots, the supply chain, the rail, the maritime industry, and all of these continuous interconnected locations and environments. Operational technology is part of all of those locations, but the threat today is unique in that this one continuous battle space is presenting us a dynamic environment of vulnerabilities that we're faced with. These vulnerabilities are changing every day. It's a race to keep up with them. We're dealing with nation states, insider threats, different types of motivations for disrupting our mission and our ability to do things. What's also interesting about looking at this threat landscape is there are so many different avenues for disrupting, what we try to accomplish, both in the commercial sector and in the federal and national security sector. And it kind of shows you that it doesn't always require a kinetic activity to disrupt the mission, right? So, the takeaway here is growing attack surface, sophisticated threat, more and more locations where those vulnerabilities can be evident. And our challenge is to understand and protect this one connected battle space. So I want to take a couple minutes and refer to, the cybersecurity governance that is out there today. One of the things I've learned by working with different practitioners, many of the folks on my team, is that there are a lot of governance and frameworks that are out there. So you, as a cybersecurity practitioner who's focused in some capacity protecting OT, protecting critical infrastructure, it's important to look at the tools that you have access to. The governance is out there. It's smart to learn about it and use it. My team in particular has found that the CISA cybersecurity performance goals are particularly useful. We employ the NIST cybersecurity framework as a helpful model that we use in the field. And the reason that these things are important is because, kind of really trying to present a mission-focused perspective here, a lot of the guidance and policy that you receive from higher levels are very much prescriptive based and not outcome based. Okay? So if you're not careful as an asset owner or a commander on the ground or some sort of cyber operations practitioner, a lot of the guidance and policy that you receive really won't present you with outcomes. What does right look like? So one of the things that I want to encourage you to do is be familiar with those existing frameworks. For some of you, this is very fundamental. For others, you might kind of be, inventing the wheel here as you start putting together your OT cybersecurity plan. So we would encourage you to take a close look at these existing frameworks, and in particular, I talked about the CISA CPGs. Useful framework, gives you an opportunity, a good start point, and gives you a path towards outcome-based goals. If I could, make one suggestion in any opportunity I have in forums of discussion is that we provide more outcome-based guidance to our asset owners and our mission owners on the ground, because we kind of need to know, what does OT cybersecurity look like? How do I know when I'm meeting goals, and what are those metrics, and what are the expectations? We are fortunate that along with the National Cyber Strategy, we have back-to-back National Defense Authorization Acts that have provided specific guidance around protecting critical infrastructure and operational technology with an emphasis on cyber-physical defense of OT and weapon systems. So that is definitely momentum for us all who are part of this mission. But it's really important that we stop, take a look at the existing frameworks that are out there to help us kind of develop our OT cybersecurity program. So, as we kind of go forward in the discussion, why not just revisit OT again? Because, it's really important to understand the uniqueness of operational technology and control systems, the impact of control systems on those day-to-day activities that we rely on in the real world. And when I'm having a discussion with people for the very first time around OT, one of the things I love to talk about is how does a garage door work? Okay? Now, for some of you, this is old hat in your experience. For others of you, you're getting into this field. So we want to really understand, OT is about processes and logic. When you think about how a garage door works, there's a set of mechanisms and logic and connections and depending in electronics that causes an activity to take place. When those processes are disrupted, that activity cannot take place. So when you look at the national security environment today and the connected devices that help to influence the execution of different missions, it's not just the weapon system itself, but it's the C4ISR system that supports those weapon systems. It's the predictive maintenance and the maintenance analytics and all those types of support systems that go into preparedness and mission readiness. It's the connectivity associated with our supply chain. It's the lighting, it's the HVAC, it's the emergency systems. And you talk about the difference between IT and OT. They're different, but they're connected, they're related. Right? When you look at attacks such as Colonial Pipeline, that was certainly an OT disruption. It was an IT infiltration that allowed those folks to get into the system that caused the OT disruption. Okay? So IT versus OT. IT is about data. OT is about physical systems and processes. Physical systems and processes that impact our daily lives. Okay? And impact the missions that many of us will support when we leave this conference this week. Any questions? So now we're going to kind of get down into a few different layers to talk about OT cybersecurity. Okay, so I don't like to get into details with either commanders, leaders, cyber operators, people who know about OT, who don't know about OT, without really talking about the Purdue reference architecture. The Purdue model reference architecture is a structural model for ICS security that depicts the segmentation of physical processes, sensors, controls, operations, and logistics. Those of you who have been around OT for some time know that this is really a long-regarded model for understanding the structure of OT from the lowest level all the way up to desktop systems. When you look at the different levels, level 5 being the top is your internet, cloud services, remote vendors, kind of where we work on a daily basis. And we're going to kind of get into each one of these levels here in a second. And when you go to the lowest level, level 0, you're actually talking about pumps, conveyors, and switches. This is where I think you kind of separate the practitioners and the people who are trying to get at the OT cybersecurity problem earnestly from those who. This isn't just an opportunity for you to look at the different levels of OT, but it gives us an opportunity to do two other things. Number one, the Purdue model is a mapping of where threats can occur. Okay? And then the Purdue model is also a mapping of where you would apply your solutions. From a very practical perspective, there's no shortage of cybersecurity vendors out there. You know, there's just great technology and great vendors out there. Many of them probably are represented in this audience. But, you know, whenever I have a discussion with a potential partner to tackle OT cybersecurity, I ask them to describe to me, where does your solution fit in the Purdue model? What part of this architecture do you protect? Very rarely do you have one vendor comes in, sits down and says, well, we protect all 5 levels. Okay? So the Purdue model gives us an opportunity to kind of figure out what the map looks like, where the vulnerabilities could be, where solutions can be mapped. Okay? And it gives you a framework of how we segment those different levels in an OT enterprise. It's interesting because, you know, when you get into some of these discussions, some people think that the Purdue model is kind of, you know, worn out its value as we move to more sophisticated solutioning and more broader scaled applications for protecting OT. But I really feel that for purposes of this discussion, and we'll kind of dive a little bit further into these levels, understanding the Purdue model and understanding these 5 levels is a very good way to understand operational technology at an OT network. So before we get into, you know, some of the specifics around OT and the different layers of the Purdue model, I did want to pass up the opportunity to kind of share some of what we call these golden rules of OT cybersecurity. And I oftentimes just like to walk around and talk, but I don't want to miss some of these notes. I really hope that, you know, this is a training class, right? So I want this to be a good blend of facts that are out there for you to take away and things that people learn from the field. Because one of the things that's, I think, unique to cybersecurity, and OT cybersecurity is no different, is the emphasis on tradecraft and experience and lessons learned and TTPs. So it's very important for me that you take away some of these things as ideas, you know, and argue, debate them, and figure out which ones apply to you or don't apply. So, you know, the CIA has the CIA triad of availability, confidentiality, and integrity. We think in OT, critical infrastructure, safety is the 4th part of that. Increasingly, safety is a consideration in protecting critical infrastructure. Depending on who you talk to, you know, we all have different mentors and luminaries out there, but this emphasis of safety of people and equipment is more and more a consideration as we look at the different types of OT threats and the motivations of threat actors, whether you're thinking of something as fundamental as you know, trying to prevent a power plant from blowing up, to thinking about electric vehicles, and all of the different ways that operational technology can be taken control of or manipulated that impacts the safety of humans. There are no gaps, air gaps, right? So when I first got into critical infrastructure, cyber, and OT, there was this talk about, well, you know, these things are air gapped and take things offline. But the fact of the matter is when you look at our network devices today, and you look at the number of OEMs and vendors that are out there installing and maintaining those network devices on various networks, there's always some sort of connection. In most cases, there are vendors and maintainers that are coming on installations from off base, and you have to ask yourself, where are the other connections that you might not be aware of? So if you're just getting into this field or you've been here for a long time, you just can't rely on air gaps as a solution and a way to protect your network. Depending on your control systems, depending on the mission, there are opportunities and needs for taking things off networks and creating different network segmentation, different things. But do not consider and rely on an air gap as a security measure. Increased visibility is of great value. I mean, this sounds pretty fundamental, right? But you can't secure what you can't see. The details of getting into the very specifics of what's happening on your network. Every ICS and OT system is different. Every installation is different. Now, what's really, one of the things that's also interesting about operational technology is you run into a lot of the same OEMs and vendors, right? We at Booz Allen have an OT cybersecurity lab where we train and test and demonstrate. And a lot of these OEMs and vendors are in all kinds of different bases and stations, but the mission of those installations, how they're maintained and the way they're connected and what they protect are different. So you have to look at that every time that you're tackling an OT cybersecurity challenge or problem, that the security requirements are going to be unique. And you have to look at those requirements with a unique eye on that mission and on that network and on that installation. Learn to live off the land. We all face a world of resource constraints. One of the things that I do want to foot stomp here in this discussion is that you can always do something to protect your OT. Every organization, has a desired budget that isn't met, has funding constraints. You never know when you're going to have an attack that disrupts your mission or slows you down. I'm not going to say you never know when you're going to have an attack, because we have to assume breach. We have to assume that networks are being attacked now. But you have to kind of have this mentality that if you're not fully funded or resourced or trained or staffed with all the OT equipment and vendors and solutions you want, you still need to prepare to work with what you got. There have been very recent incidents in our threat landscape where people's quick response and taking measures to move quickly in the face of a threat or an attack, really saved the day. So you always have to be aware of those kinds of things that you do have available to you, that ingenuity that you have to protect your network as a solution. But I will say, as if you're an asset owner and a mission owner, don't be afraid to kind of come up with some sort of OT cybersecurity problem based on the resources you have. It's interesting because, I liken it a little bit to the way we viewed data science and data analytics about a decade ago. In many ways, data analytics and data science was expensive. If you needed sophisticated solutions, you needed to have a big budget. That became more affordable. They found better ways and cheaper ways to actually have access to that kind of solutioning and those capabilities. Kind of need to look at OT the same way. We all need more resources. We all need to be advocates for more resources for OT cybersecurity. But in parallel to that, you need to think about what you can do. You need to think about how you live with what you've got and recognize that every day you wait is a day that's too late to start, looking at a way to protect your operational technology. Let's just take a look at some of the roles and responsibilities. What kind of roles are you dealing with on a day-to-day basis in an OT network? These are just a couple of them. Okay? But when you look at the lower levels of the Purdue model, you're looking at, mechanical room, the platforms, your process engineers, your technicians, programmers, operators. You can see the different types of responsibilities that you have on the ground, right? So those individuals that are actually dealing with the physical systems and devices working with the operations themselves are some of the key roles. And then very related to that, and closely aligned but different, are the supporters to those environments. The systems owners, vendors and OEMs, the integrators, the government who's providing regulatory guidance and policies and resources. So mechanical rooms, floors, operators, people hands-on, actually managing and seeing the physical systems and processes, and those individuals and those roles that actually provide support to those environments. Any questions? Any thoughts? We're going to have an opportunity at the end. I really hope to get some questions and feedback from you guys as we go. So let's look a little bit deeper into the Purdue levels themselves. What are some of the specific details that you see at these levels, at these segments of the Purdue model? This is a snapshot of Purdue model level 3, and it really represents the facility operations themselves. Okay, this is where the operations at that level. This is where operations execution, data historians exist. This is where data is collected and stored at that level of the Purdue model. And the fact that this is the location where operations data is collected and stored in the Purdue model also kind of talks to why, these levels can't be air-gapped. Okay, so when you think about level 3, you think about the site itself, the takeaway is the operations system zone where data is collected and where data is stored. Purdue model level 2 is your supervisory control and your distributed control systems layer. Okay? This is the supervisory zone, the control systems level. Okay? This zone in the Purdue model, level 2, contains the systems that supervise, monitor, and control physical processes. Okay? So level 3 is where the data is collected and stored. Level 2 is where that data is supervised, monitored, and those physical systems control processes exist. This is also where you start to see the existence of that HMI, that human-machine interface. So when you talk about the term SCADA, right, very fundamentally, if you going back to our initial discussion about the Purdue model, operational technology, there's always a little bit of misconception here. Too many times we write OT/ICS/SCADA. Okay. Operational technology is a little bit of an overarching term. Operational technology exists across the Purdue model. When you get further down into the lower levels of the Purdue model, you're dealing with the industrial control systems. Okay, across and up and down that Purdue model. But it's really at level 2 where you talk about SCADA. Talk a little bit about HMI some more. HMI is kind of, what do humans do in this process? I mean, this is a picture. It's kind of where depending on the network and the maturity and sophistication of that network, this is where you're actually dealing with interaction with the control systems. Switches, buttons, what does a human do to take something online, offline, to make a change, make a switch? It's at that Purdue model, level 2, where that takes place. Does everyone understand that? Okay, any questions? This can get a little dry here. I just want to make sure you get some good useful information, so please raise your hand, ask a question, clarify, correct if needed. Just want to make sure you guys are getting some good 10 out of this. About 10 out of this. Purdue model levels 1 and 2 is really where you have your actual PLCs themselves. Okay? Programmable logic controllers, PLC. Okay? And the PLC is actually the computer-based device that controls the mechanical process. Okay, so level 1 and 2 is the outside of 0. You're getting down to the bottom of the Purdue model, PLCs, right? These are the actual devices that control the mechanisms and the processes that push the data. Logic is executed based on the feedback of the instrumentation. So look at the example that's on here on the slide. Okay? In a server room, the PLC may be used to automate the load balancing of HVAC units while maintaining a cool temperature. So that PLC is pretty important for actually allowing those physical systems and processes to occur. Does that make sense, everybody? Okay. So, if you walk out of here and you go into, if you're new to this, and you go into an OT lab or an OT environment, and you got a chance to kind of work your knowledge a little bit. Ask where those PLCs are. Look at them. See how they're connected. See what they look like. Again, practical application. I would encourage all of you, I'll tell you, it was enlightening for me. It's one thing to talk about OT cybersecurity and to play a role in doing this, but you've got to get out there and you have to see what these things look like. You need to see the Purdue level layers in front of you to really get an appreciation. I'll tell you, one of the most enlightening experiences for me was to be downrange with a team and watching them fix stuff that was in an OT levels 1 and 2. And you see how the wiring occurs, and you kind of gain an appreciation for this stuff isn't easy. Okay, and part of this is Forbes' view. Okay, but anyone who tells you that you just call up a vendor and it shows up at your door and you install the technology and everything's fine just isn't facing the truth. The fact of the matter is these networks can be complicated, and many times you have a network that has parts of the network that have been updated and other parts and cabinets and so on that have never been touched. Okay, so having an understanding, a baseline understanding of what's a PLC, what's not, what's a SCADA system, what's not, can help you when you get out there and execute your responsibilities. And then Purdue level 1, Purdue model level 1 is, remote terminal units, field devices. Those things that are out there in the field that are collecting data, that in many cases we deal with field devices on different platforms, on different weapon systems, pulling data, sending it across the network. Okay, so these are, this example we offer here is, field device that helps do load balancing on generators. So this is level 1. This is the bottom of the Purdue model. Those field devices that help to serial traffic, right? So if you take a field, a data bus traffic that you're collecting off a different system or platform that's fed up into the Purdue model all the way up to a desktop, those field devices. In today's world, and particularly when we're talking about the Army, there are more and more opportunities to use field devices to collect data bus traffic, to give you visibility, and to do anomaly detection. That's kind of one of the things I want you to take away here is when you're getting demonstrations or even when you're walking around the venue here this week, listen to some of these demos. I'm telling you. Ask them if they're talking about OT, where does your product protect? If you have a physical system, a physical device, where does it go? How much does it weigh? Does it go on an aircraft? Does it go on a tank? Does it go on a wheeled vehicle? What does it collect? Where does that data go? See, these are the questions that we want you to be able to ask when you go back out into the field. If we're going to get this right, and really do our part to support the national strategy and really the mission, then we need to walk out of here and kind of continue to educate and inform ourselves on those tough questions to ask. That's kind of and this is a pretty good segue to really talking about some TTPs and some models that are available out there for us to help us. Any questions? Any thoughts? Anybody chomping at the bit to say, yeah, you really missed this part though, or I learned this along the way. I mean, we gotta stay on schedule here a little bit. I love this as a chance for you to say something. This makes sense. Any lessons learned? Are these things that you would tell someone just getting into the business? This is particularly important. Anything else? Yeah, go for it.
Steve Posa from CISA. Just curious, you just touched on built vehicles, rolling stock, tracked vehicles, aircraft. But the examples given here are largely facility or garrison based. So can you describe, are you going to describe some of those different?
Absolutely. So great question. I'm transitioning now into kind of TTPs. But yeah, you're right. I described the Purdue model very focused on building control systems. Okay, so when I went through these slides, yes, and I stood up here and I used an example of weapon systems. I guess when I think particularly about field devices, I'm thinking more and more about where we're going, right, and some of the challenges that we face. So, good question. Not in this review. Okay. So who here has interfaced with or heard of or uses the ICS cyber kill chain? Okay, not. So okay, well, for the rest of this discussion, we want to arm you with tools, models, frameworks that you need to use when you're thinking about protecting your network. Okay, so this is a little bit revealing. We have a number of people who are working in OT, who understand OT. You got to have some tools in your rucksack that help you protect OT. So the industrial control system cyber kill chain, I'll tell you a little history, right? In 2011, Lockheed Martin published the cyber kill chain as one of the first attempts to explain how attacks work. The cyber kill chain covers 7 high-level goals or tactics attackers should perform during an attack. Okay, so you need to understand, depending on, we often refer to this as getting at the anatomy of an attack. So ICS attacks occur in 2 stages. The first stage is the reconnaissance. So let's take a look at this here on the left side, right? This is kind of getting into the types of steps that the adversary needs to take. The reconnaissance phase, where an adversary does the research, identifies, selects the targets. Weaponization and targeting will often entail adversaries pairing remote access and malware with exploitation devices to get at the network. Once that is done, you get into delivery, which is the transmission of the weaponization itself to the target. Exploitation, once an adversary has gotten on the network, has pushed that malware, exploitation is, well, what are you going to do when you have access? Installation, it might be the weaponizer, the attacker may install a backdoor in a target system, command and control, and actions on the objective. And those of you who are operators in the Army, sometimes it's resonant, okay? But that piece is really important. And when you think about what we're seeing in the environment today, you got to think in terms of this kill chain when you're trying to examine things like Volt Typhoon, right? When you look at Volt Typhoon, we've seen an adversary there that really used to spend their time getting on our networks to steal IP. Now we see an adversary that's getting on their networks to figure out when they want to make an attack, when they want to disrupt. Okay, so you need to understand that part of the the kill chain. The second part of the kill chain is the actual attack development and execution. This is where the adversary will develop, test, deliver, install, modify, you can see, and execute the ICS. So this is a way where when we started to emerge and 20, 25 years ago, think about, there's a reality around industrial control systems and OT and their connection to, our kinetic and weapon systems and platforms and the damage that it can occur. We started using the kill chain as a way to understand these attacks. Okay, so cyber kill chain. Who's heard of the MITRE attack framework for ICS? Okay. So MITRE attack for ICS is a really important tool for understanding adversary behavior. When you look at the different phases of an adversary's attack life cycle, so this takes the kill chain and really kicks it up a notch in terms of level of detail. The model here, and there's a lot of details, provides a real taxonomy of all of the different activities that can take place during an attack. We highlight initial access and impact because, when you're talking about lessons learned from an attack and have, an entire afternoon to talk about it, you want to know how they got into the network and what did they do. Okay? Adversaries will take the path of least resistance. You need to take some time with this and study adversary habits. We're seeing them today. The brute force cybersecurity attacks that we're seeing in Ukraine now, that we're seeing attacking OT in Ukraine, are really examples of brute force and path of least resistance. And you look at other nation states, and you look at multi-form, more sophistication, more patient, more time informed. The reality of this for all of you is that you need to dissect these things and be prepared. Those attacks, that network access, it's happening now. Every one of your organization is being attacked, is being penetrated. Okay? Cyber resilience and OT cyber resilience is figuring out how to deal with those attacks to protect your mission from those attacks. So this is a tool. I'm not going to go into every little step here, but MITRE attack for ICS framework is something that you need to be aware of as an OT cyber defender. Had an opportunity to participate in the RSA conference a few months ago. Great conversation with a bunch of thought leaders, and it wasn't that long after the 5 ICS critical cybersecurity controls was published or republished by SANS. If you're new to this line of work in cybersecurity, look at the different SANS courses. Get familiar with the different training venues that are out there so you can learn the kind of tools of the trade that you need to be most effective at. But let's talk about these 5 ICS cybersecurity controls. And true story. So get ready to go sit down with some leaders to talk about this. And I asked one of my senior practitioners, what's the aim, what's the going in position? It was like 5 ICS cybersecurity controls. And there was, so let's talk about what those 5 are. These are kind of 5 fundamental things that you need to have to protect your OT enterprise. Anyone from read this, familiar with it? Okay. Number 1, you need to have an ICS incident response plan. Okay? An operations mission informed incident response plan. What do you do when an attack has disrupted your mission? What do you do and who does it? When do you do it? How do you know you've done it? The second is you need to have a defensible architecture. Okay. We looked at the Purdue model architecture as an example of how OT networks are segmented. Okay. You need to have your own architecture, how you're protecting your enterprise. When you sit down and look at your own house, or you're going to talk to an asset owner or a mission provider that you're supporting, you got to start with where are things located? What are the physical systems in process? How does the data move? What is it doing? Okay, so developing your own architecture and understanding, log collection, asset identification, segmentation, different tools that are being used, that's important. ICS visibility and monitoring. You can't protect what you can't see. Okay? Secure remote access. You need to have the ability to see your network, conduct asset inventory, see how the inventory has changed, see how the network has changed by having reliable, secure remote access. And risk-based vulnerability management. That's kind of tied a little bit to the incident response plan. You need to understand what your vulnerabilities are. It's not easy to mitigate all of your vulnerabilities, but you need to understand what they are. Okay? And you need to prioritize the vulnerabilities. Anyone heard the term crown jewels, cybersecurity crown jewels, OT? You aren't resourced, and you never will be resourced to protect everything the same way. But understanding your vulnerabilities allows you to understand what's most pressing, what's most important, and what's going to impact your mission. Zero trust for OT networks. Wanted to touch on this. A little bit of fact and a little bit of opinion. So, zero trust principles have become a significant enabler to cybersecurity. In recent months and years, we have emphasized the importance and the value of zero trust principles on OT networks. We think, and this is, we would like to examine this very closely, and that really zero trust implementation on OT networks are most successful and most valuable in Purdue levels 3 and 1, right? Zero trust and OT are engineering disciplines. I could have said this up front. OT is an engineering practice. Now, I'm not an engineer, okay? But we need engineers. We need people who are not engineers. We need people who understand the mission. We need people with all kinds of different backgrounds. But make no mistake about it, OT is an engineering practice, okay? And we need to look at it from that lens. And when you incorporate zero trust, you have to think about that as well. I will leave you with this. We look at zero trust for OT kind of as at first we know harm, right? If you are protecting your OT with a strong OT cybersecurity program, you're already doing a lot of zero trust. Okay, but just kind of start thinking about how this goes into your network and how we do this. There's some interesting idea here. Endpoints can't always be hardened, but they can always be secured. Okay, everything can't be hardened the same way, but some level of visibility, some level of solution enables a broader level of security. Detection and response dwell time directly correlates to risk. Network visibility is so important because you got to figure out who's penetrating your network, how long have they been there, what are they waiting to do. Okay, that enables your decision space. Okay, so these are things that you need to think of. We can spend the next hour talking just about zero trust for OT, but I didn't want to do this training without bringing it into the conversation. Building a culture of cybersecurity in OT. I mean, there's some different things here on the slide. I just want to talk to this. I'm serious. We got years and years of experience in this room. But I am serious that this is the window of time for us to figure this out together, to protect, use OT cybersecurity to protect our critical infrastructure because it's a huge enabler to mission accomplishment. That isn't just the engineering piece of it, it's the cultural piece as well. Okay, and all of you who are performing different roles and protecting this part of our network and this part of our mission, you need to understand the cultural aspect of it. You can't just throw IT at an OT problem. Hopefully you're getting some sense that protecting operational technology requires some unique training and understanding. We've probably all heard that, yeah, we've got OT covered, we should put some of our IT at this. IT is not OT, OT is not IT, they work together. So you need to think about the cultural aspect. This is a transition. This is a transition within your organizations. I'm really glad that we have CISA here. I mean, to kind of get, if you talk about shields up, right, setting the tone for how do we look at this from a cultural perspective. I mean, that's been revolutionary for us in this field. But when you get into your organizations, building the culture of cybersecurity is really important. And that's roles, responsibilities, relationships, communications, interaction. IT and OT need to talk to each other, need to work together. Operational commanders sometimes don't think about this. Installation commanders need to think about OT, and you need to have those types of relationships. So wrapping up, kind of 4 takeaways that I hope you're getting from this, but this isn't intended to be, this is intended to stimulate thought, thinking, and to help you start or continue your journey in this field. But this is a dynamic and growing threat. Okay? We have a strategy. You don't have to go far to read about the latest attack. But this is a dynamic and growing threat. We don't have enough people to solve this problem. We don't have enough mission understanding to do what we need to do together. Okay, so I'm not trying to be alarmist here, but the fact of the matter is our critical infrastructure is at risk. It is at risk. Okay? I went to to the store with the Home Depot 2 weeks ago, and one street light was down. And all chaos broke out in our town in Northern Virginia because of street lights. Can you imagine the impact that a large-scale OT cybersecurity attack can have on our infrastructure? We've seen it. Understanding OT networks. I understand I kind of went high, kind of went low here. But you can't do the big understanding. You can't talk strategy. You can't have credibility with the people you support unless you understand the E's. I've learned this the hard way at times. You got to understand OT. You got to train yourself to understand enough to talk intelligently about it. TTPs for OT cybersecurity. There are a few in this deck. Happy to build a connection with you and talk to you about it. But you got to have a toolkit. It's not good enough. You can't make up. There's enough out there to learn from and to apply to use. You never should start cold. And your role is essential. I don't care if you've been 1 year or 10, 20 years, if you're at DoD, if you're at the asset owner level, or if you're commanding an installation, this is an important role for you, and we have a mission to work at together. This is a team sport, and we need to share information. You need to listen, you need to be able to share, train, and we all have to work together. So I got 2 minutes left for questions. I didn't plan any questions. I would love a couple hard questions. We got lots more people in the room. Yes, sir.
Chuck Wilson from Mission Command. You mentioned a brute force attack on your OT systems. So in both electronic warfare, consider brute force, a lot of power, micro-security, and all that, versus very refined modulated techniques in cyber. Can you give an example of the brute force attack?
Yeah, it's similar to how you describe power. Very simple, quick, unsophisticated attacks on power networks that just enough to bring down the network and cause disruption to CAS. To me, a brute force attack, and I welcome opinions, is something that does just enough where the adversary maybe hasn't been on the network for very long at all, but did just enough to knock something off, knock something down, to cause the lights to go out, to cause the power to be disrupted, to cause a boiler to blow up, to cause something that created havoc and disrupted the mission. Versus a sophisticated, zero-day, attack where an adversary has been on the network for a long time and has a range of lot of options and levers. So I think your analogy of an actual attack on power is similar, but that's, without getting into the specific adversaries, that's kind of what I meant by brute force. Got time for another question? Pat's going to kick me off here in a second.
I don't want to kick you out, but I want people that were here for the full 60 minutes to get credit. Please use your integrity, and only those people that were here for the full 60 minutes get your credit, get your scans and scan at the back. If you're an AFCEA member, you will get the credit. If you're not an AFCEA member, you're still going to have to self-certify. They will send you an email to tell you which courses that you did. If you're not an AFCEA member, you can go downstairs and join at booth 123. But I think this is an important subject. I keep reading a lot of these fiction books. One of the fiction books I took down 5 different nodes in our electrical grid and shut down the whole nation. And I can see things like that happen. It's a very, very important discussion. So if somebody else has some more questions, please do. But those that want to get credit, please go scan your badges.
Great. All right. And feel free to stop up, and thanks for your time today.